Hello and welcome to your geometry recording for the week of week 10, and we are in the week of October 18th. So at this time, please make sure that you have your math notebook out and go ahead and answer the question below in your math notebook. And this is a warm question to get you thinking about some terminology that you're going to see this week in geometry when you go to do your lessons in Schoology. And that word is bisector. So what does bisector mean in geometry? So we've learned about what it means to bisect something. So think back of what we learned of what it means to bisect something to see if that will help you figure out what a bisector is in geometry. And if you need to, do a quick web search. Type in what is a bisector in geometry. So go ahead and do that and click pause and write your answer down in your math notebook. So what did you find out if you did a web search, or what did you write if you already knew what bisector means? So bisector, when we're talking about geometry, means that it is a line that divides something into two equal parts. A line that divides something into two equal parts. Well, what is the something that we're talking about? What could the something be? So it could be an angle. We could have an angle bisector. So if we had an angle, the bisector would divide this angle into two equal parts. So this could be our bisector. It would cut it into two, divide it into two equal parts. So we could say that this angle would be 40 degrees and this angle here would be 40 degrees. Both the angles would be 40 degrees because the bisector divides that angle into two equal parts. We might have a segment bisector, where if we just have a segment, our bisector is going to divide that segment into two equal parts. And that kind of doesn't look exactly equal, but we could say from here to here is 5 inches, and from here to here is 5 inches. So a bisector is just something that divides something into two equal parts. And we're going to see this vocab word this week when we're working in Schoology. So what are we working on this week? We're going to complete 3 sessions, session 9, 10, and 11 in Unit 2. And remember, we're still focusing on triangles. So Unit 2 is all about triangles. So this week we're going to explore bisectors of triangles. Whoop, there's that vocab word. We're also going to explore medians and altitudes of triangles. And then last but not least, we are going to explore the triangle mid-segment theorem. So again, we're still focusing on triangles in Unit 2. So let's jump in and talk about some different segments that we find in triangles. So really what we're focusing on this week is the different segments that we can find within triangles. And 2 of those segments are medians and altitudes. So let's first start talking about medians and altitudes. So a median is a segment within a triangle, and that segment is going to join a vertex of a triangle. So right here, here's that vertex. So here we've got the median in red, and it starts at the vertex, and then it goes through to intersect the midpoint of the side opposite that vertex. So remember, midpoint is going to divide a side into 2 equal parts. So we start at a vertex, and then we intersect at the midpoint. So the segment from here to here would be equal to the segment from here to here that the median bisects. So median goes from the vertex to the midpoint. Intersects at the midpoint of the opposite side of the vertex. And that is a median. That is a median. So a median is one type of segment we find within a triangle. Another type of segment we find within a triangle is the altitude. So the altitude is also a segment within a triangle, and it is a perpendicular. The altitude of a triangle is a perpendicular segment with one of its endpoints starting at the vertex. So same thing with the median. We start at a vertex here. But now with an altitude, instead of intersecting at the midpoint, we have to intersect so that the other side is, we intersect it perpendicularly. So opposite of the vertex, the altitude has to intersect perpendicularly. Remember, that means that we have to have a right angle. So here we have a perpendicular segment. Perpendicular means that we intersect at a right angle. So at one side we start at the vertex, and then we have to intersect the other side at a right angle. So the opposite side of our vertex, when we intersect, we have to do so at a right angle, a 90-degree angle, a perpendicular segment with the side opposite the vertex. So that is in altitude. So they're similar in that they both start at a vertex, but they intersect the opposite side of the vertex in a different way. Median at the midpoint, M and M, median at the midpoint, and then the altitude has to intersect the side opposite of the vertex at a right angle. It has to be perpendicular. So they're similar, but they are different in the way that they intersect opposite the vertex. So I'm going to go to the next slide, so if you need more time to make your, jot down some notes about altitudes and medians, go ahead and do so. Click pause so that you can write down good notes. All right, we talked about bisector already, and a perpendicular bisector, who kind of already chatted about this. The definition of a perpendicular bisector is it's a perpendicular line or segment that passes through the midpoint of a line. So here we're combining two words that we've chatted about. Perpendicular means that it's got to intersect at 90 degrees. Bisector means it cuts or divides something into two equal parts. So now we're combining these two words so that we can now have the definition of a perpendicular bisector. And it's exactly what you think it is. It's a perpendicular line or segment that passes through the midpoint of a line. It's got to cut the segment it passes through into two equal parts, and it does so at a 90-degree angle. So we could say that down here is a nice diagram where we've got line AB would be a perpendicular bisector of segment QP, PQ, because it intersects it at a right angle and it cuts it into two equal parts. So a perpendicular bisector divides a line segment into two equal segments and intersects it at a right angle. And that is what a perpendicular bisector is. So we have a perpendicular bisector theorem that you're going to be learning about this week. And the perpendicular bisector theorem states that any point on the perpendicular bisector of a segment is equidistant from the end points of the segment. So what does that mean? What does that mean? So here, let's look at this diagram and kind of put that definition into a diagram and understand it a little bit better. So here's this black line here, segment CD. This segment here, segment CD, is the perpendicular bisector of segment AB, because we can see that it bisects the segment at a right angle, and then when it bisected it, it did it so at the midpoint, because it divided segment AB into two equal parts. So any point on the perpendicular bisector, so let's say point F is going to be the same distance from the end points of line segment AB. So what we're saying is the distance from A to F has to be equal to the distance from F to B. So these distance from A to F and F to B have to be the same distance. Same with if we talk about point E. So point E is a point on the perpendicular bisector. So the distance from A to E is going to be equal to the distance from E to B. That's all it is. So really any of these dashed lines, we're saying that the distance between each of the endpoints to that point on the perpendicular bisector has to be congruent. It has to be equal. So let's look at an example of putting the perpendicular bisector theorem to use. So here we've got a diagram. What can you tell me about segment NP? What can you tell me about segment NP? Can you tell me what the name of it would be? Can you classify what that segment is? So look at that little square there. Tells us that it's perpendicular. NP is perpendicular to MO. What do those little red ticks tell us about NP? Those little ticks tell us that NP intersects at the midpoint of MO. So NP is a perpendicular bisector. NP is a perpendicular bisector. Point N falls on, is a point on the perpendicular bisector. So can we find the value of X? If I asked you to find the value of X, do we have enough information that we can find X? Can we? Can we find the value of X? Do we have enough information? Aha! Well, we know from the perpendicular bisector theorem that point N falls on that segment, that perpendicular bisector. We also know that the distance from N to our endpoint M has to be equidistant from N to O. That's what the midpoint bisector theorem tells us, that the distance from N to M has to be equal to the distance from N to O. So we can just now substitute in the values that we were given for the length of each of those segments. And now it's just a simple algebraic equation where we're solving for X. So to solve for X, I want to get all of my X terms on one side of the equation and all my constant terms on the opposite side. So I'm going to start by subtracting 3X from both sides. And then I'm left with just -2 on the left. I've got 3X minus 14 on the right. So I got to move that -14 to the other side. So I'm going to do that by adding 14 to both sides. And I'm left with 3X equals -2 plus 14. So we got 12. Now we're just going to divide each side by 3, and I get X equals 4. X equals 4. So I'm going to go on to the next slide. So if you need more time to jot down the notes on how we use a perpendicular bisector, go ahead and do so now. Alrighty, so let's talk about perpendicular bisectors when we talk about being within a triangle. So we already know what an altitude is. Remember, an altitude starts at a vertex. To be an altitude, we start at a vertex, and then we have to cross the opposite side at a right angle. We have to be perpendicular when we intersect the opposite side of our vertex. Well, let's talk about perpendicular bisectors being a segment in a triangle. So to be a perpendicular bisector, we have to intersect at a 90-degree angle, and we have to be a midpoint. We have to intersect at the midpoint. So in this case, we're not starting at a vertex. If we intersect, if this line, if we keep making it continue, it's not going to intersect at a vertex. But what's important is that the intersection of the segment is at a 90-degree angle, and then it divides the side into 2 equal parts. So that's our last type of segment that we're going to chat about for parts of triangles. So we have medians, altitudes, and perpendicular bisectors. Let's do a quick concept check. Altitudes and perpendicular bisectors look very similar, don't they? Here's an altitude and here's a perpendicular bisector. So altitudes and bisectors look similar, but are they the same? So again, here's an altitude. We start at a vertex and we intersect at 90 degrees opposite of the vertex. Here is a perpendicular bisector. Are they the same thing? They are not. So what is different about them? So there's a 90-degree angle in our perpendicular bisector and a 90-degree angle in our altitude. But our altitude, look how it intersects the side opposite of our vertex. It doesn't intersect the segment opposite the vertex into 2 equal parts. Where to be a perpendicular bisector, we have to intersect into 2 equal parts. In this case, this is the bisector, the perpendicular bisector. It happens to start at the vertex. This isn't always going to be the case. So for it to be a perpendicular bisector, we don't have to always intersect through the vertex. So I just want to label this one as the perpendicular bisector. So we can see here these perpendicular bisectors, if we continue the segment, none of them would cross at the vertex. All right, and let's not forget about medians. We talked about these at the beginning of the recording. A median always starts at a vertex and intersects at the midpoint. So vertex to the midpoint. It does not have to be at a 90-degree angle. It just has to intersect at the midpoint. All right, so let's compare them all. So if you guys, as you were paying attention, you probably noticed that there was 3 things really that we were chatting about when we were talking about all of our segments within a triangle. Whether they intersected at a right angle, whether they intersected a side at a midpoint, and whether they intersected a vertex. So each of our 3 types of line segments in triangles, whether it be the perpendicular bisector, the median, or the altitude, only needed 2 out of these 3 conditions. It only needed 2 out of these 3 conditions. So let's make a nice little chart that will help us remember which each segment has to have, which 2 conditions out of the 3. So let's start with the perpendicular bisector. When we are talking about perpendicular bisectors, does it have to intersect at a right angle? It does. There's that word perpendicular, which means right angle. So it's got to intersect at a right angle. Does it have to intersect at a midpoint? Well, there's the other word, bisector, in the name of the segment. Bisector means cuts into 2 equal parts, which is what a midpoint does. So a perpendicular bisector has to have a right angle and it has to intersect at the midpoint. Those are the 2 conditions it has to satisfy to be a perpendicular bisector. What about a median? What about a median? So remember median, I always say think of the M, the median, and midpoint. So a median intersects one side of the triangle at the midpoint, and it also starts at the vertex. It does not have to have a right angle. It might, but it does not have to intersect at a right angle. Last but not least, we've got altitudes. And an altitude, remember, also starts at a vertex. And then the altitude, where was our altitude, has to cross at a right angle. So you can see out of all 3, they each have to have 2 out of those 3 conditions. So I'm going to go on to the last slide. So if you need more time now, go ahead and click pause so that you can copy down this chart. That will be very helpful for you. Okay, I'm going to put up the key phrase assignment. So I want you to tell me a little bit more about 2 types of the segments we learned about today when we were talking about segments within triangles. I want you to tell me what's similar about altitudes and medians, and then what's different about altitudes and medians. And I included the directions on how to complete the key phrase assignment for this week in case you need a reminder. And as always, if you need any help as you're working through this week's assignments, let me know. Have a great rest of your week.